Hello and welcome. I'm your host and speaker Siddharth. I'm Senior BI Developer at Infometry. Thank you for taking the time to join us today. In today's webinar, I'll be talking about APIs. You will leave with API and how it can help you. Feel free to drop any question on the topic or share your struggles and experiences during this live session. We will answer your queries through chat. Let's start the session. The session is organized by Infometry. We are a pure play data analytics company based out of Fremont, California, with our offshore development center in Bangalore, India. We came into inception back in 2010, and since then we have been offering domain-specific analytics solutions for high-tech, energy, life sciences, retail, manufacturing, and finance customers. Infometry has been an engineering and consulting service partner for companies like Informatica, Matillion, Snowflake, Tableau, Adaptive Insights, Looker, etc. Infometry offers domain-specific analytics solutions for high-tech life science, retail, manufacturing, and finance customers. In addition to services, we also developed more than 15 cloud connectors for Informatica. One mentioned under the blue blocks are developed and owned by us, and the rest are all developed by us, only for organizations like Informatica, SAP, Calidus, etc. We have developed state-of-the-art analytics solution, Infofiscus, which can be hooked to any on-prem or cloud CRM, ERP, or planning applications. Infofiscus is 100% cloud-based pre-built analytics software developed using open architecture. Infofiscus comes in 3 flavors: finance, supply chain, and sales and marketing analytics. That's our quick introduction, and now let's move to our today's agenda. Today's agenda is on introduction to API and its role in business intelligence. So what is an API? API or REST API, SOAP API, we hear a lot about APIs. By definition, API is a particular set of rules and specifications that a software program can follow to access and make use of services and resources provided by another particular software program that implements that API. In layman terms, API is a messenger that takes the request and tells the system what to do and returns the response back to you. With API, applications interact with each other without any knowledge or intervention for the user. Let's see how API works. APIs are made up of 2 related elements. The first is a specification that describes how the information is exchanged between programs, and it is done in the form of a request for processing and return of necessary data. The second is an interface written to that specification and published for use. So a client application initiates an API call to retrieve information, which is known as a request. This request is processed from an application to web server through API URL, and this URL includes verb, header, sometimes a request body. After receiving a valid request, the API makes the call to the external program or web server. The server sends a response to the API with the requested information. The API transfers the data to the initial requesting application. Now we'll see what are the different types of API. There can be different set of API classification. There can be classification based on different criteria. So basically there are 4 basic type of APIs: private, public, partner, and composite. Let's go through each of them in brief. Internal APIs. Internal APIs are also called as private APIs. So internal APIs are published internally for the use of companies' developers to develop its own product and services. These are not exposed to any third party and are not publicly available. So these are intended to improve the productivity and communication across different internal teams. Internal APIs provide access to sensitive resources within an organization. So they simplify the process of linking backend systems or data between different teams or different applications across the same organization. The new application created by these developers can then be distributed publicly. And internal APIs can, to a greater extent, reduce the time of creating applications as well as resources required for the system integration. Instead of creating applications from scratch, developers can use the same internal software asset. Now let's see what is Open API. The API evolved through internet, from closed libraries to open APIs. Open APIs doesn't mean free, it means open as you would like. So an open API is also called as a public API. So this public API is made publicly available to software developers. Open APIs are published on the internet and shared freely, allowing the owners of the network accessible service to give a universal access to the consumers. The example of the open APIs are Facebook API, Twitter, Instagram APIs. Now let's see what are partner APIs. So partner APIs, as the name suggests, it can only be used with specific partners. So the access for these APIs will be given to specific partners with whom the company agrees to share the data. Partner APIs are used within business relationships, often to integrate software between partnering companies. The developers can access the APIs in self-service mode through the public API developer portal. Still, they will need to complete an onboarding process to get the login credentials or access tokens to access the partner API. These are mainly built using REST principles and follow HTTP rules. This ensures the predictability of URLs that make it easy to write and retrieve data related to your partner store. Now let's see what is Composite API. Composite APIs are useful in microservices architecture, where programming is in a single task may require information from several sources. And Composite API combines all the multiple requests from the API and it may be address related or independent task. All these requests are bundled into one and called as a single API call. Composite APIs are designed to batch API requests sequentially into a single API call. Rather than multiple round trips to a server, the client can make one API request with a chain of calls and receive one response. The Composite API provides a design solution that is more efficient for the client. As I said, instead of making suppose 5 requests, we can make a single request. Rather than parsing 5 or more responses, all the necessary data is passed at the end of the sequence. As I said, there can be multiple bases of API classification. So APIs may further be classified as local API, program API, or web API. So local API is the original form of API, which is the OS API that provides services to any front-end application or requesting service or data from the backend, such as any data from database. Then program API is based on RPC technology, that is a remote procedural call. This makes a remote program execution from any other server. SOA or Service-Oriented Architecture API are a sample of Program API. Web APIs are designed to represent widely used resources such as HTML pages and are accessed using HTTP protocol. Any web URL activates a web API. Web APIs are often called as RESTful because the publisher of the REST interface doesn't save any data internally between the requests. It means it is stateless. Now let's see what are the different types of API protocols. API come with a defined set of calls and techniques which are utilized by developers to successfully integrate them in their software. The rules which govern the use and application of these calls are termed as API protocols. The protocol defines the accepted commands and data types, among other things, and a certain standard of the API usage. Some of the common API protocols are SOAP, REST, JSON RPC, gRPC, XML RPC, Apache Thrift. Let's see these protocols in brief. So SOAP API protocol. SOAP stands for Simple Object Access Protocol. It is a highly structured message protocol that supports multiple low-level protocols. It is the oldest API protocol still in use. API uses XML files to transfer data between web services. These XML files are sent over HTTPS transmissions, as is common on the internet. With SOAP APIs, it is easier to share information between applications or software components that are running in different environments or written in different languages. However, SOAP also provides flexibility and enables data transmission over other protocols such as TCP, SMTP, and UDP. Messages in the SOAP are encoded in XML specifically and have a proper defined format. It contains an envelope, which literally envelops the entire message or the data in tags. Then it has a header. The header defines all the extra information that might be needed to process this data. Then we have body. Body is the place where we actually write the request from the data required. We have fault, which defines all the errors that may arise in the data during the transmission and measures to handle them. Now let's see what is REST API protocol. So REST stands for Representational State Transfer. A REST protocol overcomes the SOAP dependency on XML by supporting data transmission in multiple formats such as JSON. So JSON is the most prominent data type. Then we have HTML, Python, plain text, as well as PDF files. However, REST relies on HTTP for data transmission, takes away the SOAP's adaptability to other protocols. API which employ the REST protocol are called as RESTful APIs. So REST API follow a client architecture, which means that there is no official standard, unlike any other protocol, and it must be stateless. Stateless communication means there is no client data stored between the GET request. These GET requests must be distinct and disconnected. REST assigns every operation a unique URL. So when the server receives a request, it knows which instruction to execute to fulfill the request. REST also supports caching. So browser can store the result obtained from the request locally and retrieve it periodically as needed. This increases the speed and efficiency. So let's talk about the components of REST request. Typically in a REST request, we have endpoint. So endpoint is the destination URL from which data is being requested. There is method which are the pre-defined methods to get the data. We have multiple requests like get, post, put, delete, etc. to fetch the data. These methods vary from one another. Then we have headers. Headers define the request details and dictate the proper format in which the response must be received. We have body, which is the actual data sent by the service. We also have parameters, which specify the variable elements like URL path, query parameter, header, or request body. Now we know what an API is. Let's talk about web services. By definition, web services are the software components that transfer specific data or information over the web through protocols like HTTP with XML language. Therefore, by definition, web services requires a network. As web services exposes applications, data, and functionality, in effect, every web service is an API. However, every API is not a web service. Most of the standard web service use various components such as XML. So XML is used to tag the data. It uses SOAP, WSGL. So WSGL is used to describe the services available, and UDDI, which is used for listing what services are available. We'll talk about the basic, like the most common types of web services, which is RESTful web service and SOAP web service. So RESTful web services are basically REST architecture-based web service. In the REST architecture, everything is a resource. In the SOAP web service, we follow the SOAP protocols. Web services allow different web applications from different sources to communicate each other without any time-consuming custom coding, because all communication is in XML. For example, Java can talk to Perl, Windows application can talk to Unix application, etc. Let's see what is SOAP web services. SOAP web services describe a standardized way of integrating web applications using XML, SOAP, WSGL, UDDI. These are open standards and are over Internet Protocol backbone. In addition, each message contains XML document that needs to be transferred for communication between client and server. SOAP web service have standards for security and addressing, which is not there in RESTful web service. What are RESTful web services? So RESTful web services are also called as REST API. which is based on REST technology, in which web applications that uses HTTP request to get, put, post, and delete the data. REST technology is generally preferred than the more robust SOAP technology because REST leverages less bandwidth and makes it more suitable for internet usage. With the cloud use on the rise, API are emerging to expose the web API. So REST is logically the better choice for building API that allow users to connect and interact with the cloud services. Now we'll see the difference between REST web services and SOAP web services. RESTful web services are stateless. You can test this condition by restarting the server and checking if the transaction survived. For most servers, RESTful web services provide a good caching infrastructure over HTTP GET method. This can improve the performance if information the service returns is not altered frequently and is not dynamic. Service providers and consumers must understand the context and content being passed along, as there is no standard set of rules to describe the REST web service interface. REST is useful for restricted profile devices, such as mobile, for which the overhead additional parameters are less. REST services are easy to integrate with existing websites and are exposed with XML so that HTML pages can consume the same with ease. There is little need to refactor the existing site architecture. As such, developers are more productive because they don't need to rewrite everything from scratch. Instead, they just need to add the existing functionality. A REST-based implementation is simple compared to SOAP. REST does not enforce any message formats such as XML or JSON, whereas SOAP is XML-based messaging protocol. WSDL describes a common set of rules to define the messages, bindings, operations, and location of the service. WSDL is akin to a contract to define the interface that the service offers. SOAP requires little plumbing of code than REST. Security, coordination, addressing are some examples. Most real-world applications are not simple and support complex operation, which requires conversational state and contextual information to be maintained. With SOAP approach, developers don't need to write plumbing code into the application layer. SOAP web services such as JAX, WS are useful for asynchronous processing and invocation. SOAP supports several protocols and technologies, including WSDL, XDS, and web service addressing. Now I'll talk about security frameworks. API security is the process of protecting APIs from attacks. Because APIs are very commonly used and because they enable access to sensitive software functions and data, they are becoming a primary target for attackers. API security is the key component for web application security. APIs may have vulnerabilities like broken authentication and authorization, lack of rate limiting, and code injection. We'll talk about some concerns over the API security. Talking about broken object level authorization, APIs often expose endpoints handling object identifiers. Any function that accepts a user input and uses it to access the data source can create a level access control issue, which widens the attack surface. You should always carry out object level authorization checks for all such functions. Another concern can be on broken user authentication. Attackers often take advantage of incorrectly applied authentication mechanism. They may compromise an authentication token or exploit flaws in the implementation to pose as another user. If the system's ability to identify the client or user is compromised, so is the overall API security. Talking about excessive data exposure. Developers often rely on client side to filter out the data before displaying it to the user. This can create a serious security issue, and data must always be filtered at the server side, and only the relevant information should be delivered to the client side. Lack of resources and rate limiting is also a concern. API often don't restrict the number of size resources that the client or user can request. This can impact the performance of API server, resulting in denial of service. And exposing authentication vulnerabilities, enabling brute force attacks. We talk about the last concern, that is injection. You must have heard about injection, SQL injection, NoSQL injection, command injection. So injection flaws involve data that is sent to an interpreter from an untrusted source through the command or query. Attackers can send malicious data to trick the interpreter into executing dangerous commands or allow the attackers to access the data without any necessary authorization. We talked about overall API security. Now let's see what is the difference between the REST and SOAP API security. SOAP offers extension to the protocol that address security matters. SOAP is based on W3C and OSS recommendation, which includes XML tokens, XML encryption, and XML signatures. SOAP supports the web services specification, which lets you use the security extensions like WS Security, which provides enterprise level security for web services. SOAP supports WS reliable messaging also, which provides built-in error handling. Talking about REST API security, it does not have any built-in security capabilities, and the REST API security solely depends on the design of the API itself. Security must be built in for data transmission, deployment, interaction with the clients. REST APIs do not have built-in error handling and needs to resend the data when an error occurs. A common architectural choice is to deploy REST APIs behind an API gateway. Clients connect to the gateway, which acts as a proxy, and not directly the REST API. This allows many security concerns to be addressed by the API gateway. In conclusion, some SOAP APIs are more secure by design, but REST APIs can be made secure depending on their implementation and the architecture selected. We'll talk about the best practices. Before that, we'll see what are some bad practices in API. Some of the bad practices include poor documentation, inadequate support, poor developer experience, unexpected release cycles, security complexion, exposure to underlying data model, ignoring HTTP rules, and poor error handling. Now let's see what are the best practices in API. We must follow rules and regulations of the country. So this can be the first best practice. So laws and regulations vary across countries and industries. So developers must follow the rules of the target country or the industry, else it may be paying a hefty fine. Second best practice can be bundle requests to reduce the latency. APIs are used to transfer data between software services, devices, etc. Minimizing the number of calls reduces the latency, which results in a better user experience. APIs should also be capable to scale. When the development, we have to keep in mind that we can scale the API so that API don't go down when many requests are hit, else crashing the app. Security is the top priority in most industries, and API should follow the same concept. It's best practice to authenticate and authorize your consumers so that they can only get access. Also, more testing results in less failure after the publish of API. Testing cannot be done after the API is published. It needs to be done before publishing. The more tests, the better. And this will allow the extensive results that can be analyzed and improved if necessary. The upgrading should also be simple. The versioning is just the add of new features, and it should also be backward compatible. Talking about documentation of API, it is the most essential part of the API. This is the thing which a developer first refers to. Also, APIs must be industry standards. You can use most prevalent standards available, RESTful APIs, JSON, XML, etc. These are the standards that most developers are familiar with, so it makes it easy for the consumers to work with your APIs. Now we'll see API economy. Now let's talk about API economy. API economy is a general term that describes the way APIs can positively affect an organization's profitability. An API is a customer interface for technology products that allow software components to communicate. There was a time when only software professionals knew about APIs. Today, business leaders are aware of the financial impact APIs can have, and companies are generating revenue by exposing APIs as business building blocks for third party applications. The emerging financial effects of APIs on business have gained momentum thanks to the mobile and social media technologies. Major companies that have gained revenue from APIs include Salesforce.com, Amazon, Facebook, Twitter, and Google. Now let's talk about API management market potential. The global API management market was valued at 2.2 billion in 2021 and is projected to reach 45.1 billion by 2031, growing at a rate of 34.5% from 2022 to 2031. The API management market is influenced by factors such as rise in penetration of smartphone and internet access across the globe. It also influenced by need of customer satisfaction and to enhance customer experience. In addition, functions of the API market that are connected for publishing, documenting, and managing the application programming interface are covered in global API market research. These are used to get access to a secure environment. All of these things work together to form API management. The API management market major goal is to enable and help a company that publishes the API to track the life cycle for that interface. The approaches to cater to the need of developers are also an important aspect of how the API market works. Furthermore, firms all around the world are implementing strategies to deal with their application programmer interface in order to respond swiftly to the change in the client's requirement. This is the primary factor that is projected to drive the growth of global API management market. Through API management, organizations across several business verticals are focusing on insights as well as altered suggestions, items lacking, and offered based on gender, location, behavior of the client. Major API market growth factors include demand from the public and private APIs to accelerate digital transformation, increased mobile application in users, and social media penetration. That's about API management market potential. Thank you. My name is Siddharth. You can contact me through above contact details. Hi everyone. If you have any questions, you can ask.
Hello, sir. I'm Lakshman.
Yeah, hi Lakshman.
So my question is, what is the first step we need when working with any given API requirement?
Okay. So suppose you are given with any API requirement. So first thing I'll say it will be the documentation. So you can go through the documentation and because see, there can be various types of API, right? The design can vary. Some can have different types of authorization. The parameters can vary. So first thing is that you can go through the documentation. So that will be a better approach.
Okay, thank you.
Hi Siddharth, myself Anmesh.
Hi.
Yeah. Like what is the main difference between web services and API?
Okay. So the basic difference between API and web service is that API does not need any internet. Means API can work with or without internet, but in web services, internet is must. That is the basic difference between API and web service.
Okay, got it. Thanks.
I see that this is Manohar.
Okay.
I know what is get and delete operations. May I know what is the difference between put and post operations?
Yeah, so post means you are creating something in the target. So get means you are retrieving, delete means you're deleting. So post means you are adding something in the target, while put means you are inserting it. Even if it is there, it will insert it again. So for update, you can choose both. For the insert, you can choose both of them, but update, we can choose only the put command.
Okay. Thank you, Siddharth.
Yeah, thanks.
Hi Siddharth, this is Bharat.
Yeah.
So how can we test the API?
Means we have many, like API testing contains UI testing, data testing, security testing, authorization testing. So in API testing only we have various kinds of testing, and you can opt for the open source platforms like Postman or SOAP UI to do the testing. Any other question?
Yeah, hi Siddharth, Ritesh here. So what is the main difference between put and catch?
Put and catch.
Catch.
I'm not aware of catch.
Catch is there, right?
Oh, cache. Can you spell that?
PATCH.
Okay, catch. Actually, I have not used this catch operation. Anyone else? I guess that's it. Rohan, can we stop the session?
Yeah.
Okay, thank you everyone for joining the webinar. And Hari, I will come up with you with the catch. Okay, I'll explain you. So I'll get through that catch function and I'll get with you.
Okay. It is a patch, PATCH, P for
Okay,
parrot.
patch. Okay.
Yeah.
Yeah.
Okay.
Yeah, sure.
Thank you, Siddharth.